Okay, so let's get started. At the beginning, this is really a simple Rhino file. So if I hide, you can see it's just a bunch of lines, right? You can do this in the drawing 1 and 2. Use Maya to create animation, or you can extract the lines from 3D objects and then make 2D. So whatever way you did, it's just a simple group of lines. Really basic. So my plan is I want to use these lines as input and create a sequence of three-dimensional objects, kind of like a city kind of conceptual model. The goal is to create something like this, all right? Very complex with some frame 3D structures. So I will open my Grasshopper file and then I will explain the whole procedure, how to take these lines into a model making process. Okay, so let's open that. I think the best way to describe is I'm going to turn on the only draw preview based on the selection, this green bucket. So it's only display my current selection. So I will select this node one by one from beginning to the end. Okay. So first part is I will load all the lines into Grasshopper. Right? So this is the curve component. I think everybody knows that. You can just double click and type curve. You can search and find this component. So the goal is pretty simple. I want to load all the lines into this equation, right? Into Grasshopper. And then I want to create zones. The first thing I want to do is create a bunch of kind of patches of surface based on these curves. So one technique you can do that is using this guy. The name is a surface split. It will use line as the trim, as a cutting edge to subdivide the surface. That's a quick way you can create zones. I know in the drawing 1 and 2, the curves maybe is super complex, right? It might take forever to calculate for every single zone. So my suggestion is create a new surface. This is actually a new surface. If I unhide, let me just type unhide. Okay, let me hide this guy. You can see this is a new surface, the NURB surface I created in Rhino. Just by using this guy, define the two corners, right? Then you can create a new surface, simple like that. So my goal is I want to take the surface into the equation. So here is a load surface in Grasshopper. Then this surface became the kind of like the base cutting plan. Then it fit into this guy. So if I hide the surface again, and I click this one, and roll over, you can see I have 51 fragments. Did you see that? So because I have many lines intersect, right, to the surface, to the plan has been subdivided into small pieces. That makes sense? So you got 51 pieces now. So that is a fragment. Then the next thing I do is I will detect the center point of each fragment. So this is the area, the node, which will give you the centroid for each piece. So you can see definitely for this corner, this is the center point, right? Makes sense. So you get center point for every single piece. Then I'm going to scale. I will scale this down. And you can control the factors between 0 and 1, right? So you can resize the individual pieces. So the goal is you kind of get these offset effects for every single piece. So this is one way you can create zones based on the curve. So you could imagine if I move the curves, everything will update, right? It will recompute every single zone. So here I have all the zones. Then the next thing I want to do is I want to extrude these zones into 3-dimension, right? In this case, it should be z-axis, right? I want to extrude up. So here you can see this is the unit z, which define the vector, the orientation is vertical. The values I want to extrude along the z is actually random. So here is a random component. Looks like a little cat right here. So here I can define the range of this random point is between these two values. All right. And the number I want to have 51, right? Because I have 51 pieces. So this 51 is come from this node. The name is the list length. All right. It will detect how many pieces in the scale. There are 51, and then tell you, okay, this value is 51. Then I feed 51 as number. As a result, Grasshopper will give me 51 random number between these two values. That makes sense. It's kind of like a simple mathematical values between these two. And then I feed this into the extrusion. So as a result, you can see each 3-dimension mass is different height, right? And the height is defined purely by these two values. So in case you want to give a much higher one, I can just simply change 5 to 15, for example. Click OK. And then I click this extrusion. You can see it's just recompute based on the new range. Right? So the random values kind of get more kind of magnitude in terms of changing. It's pretty clear, right? For the first piece, it's getting this really simple massing. The one at the bottom is kind of the same. Is also take all the individual lines, and I think here I did offside. This is just alternative way. If you want to create a 3-dimension volume, you can create a offside based on the curve. So here you can see the original curve. This is offside 1 unit, right? So that's the thickness. And after you did offside, you can merge the offside version with the original version. So is original one, offside one, so they became a pair, a couple, right? So D1, D2. D2 is the offside one, D1 is the original. Then I create a loft. This is exactly like Maya or Rhino. Loft, you have two curves, then you can create this kind of surface in between. So that's loft. All right, so you basically convert lines into a surface. And then I did the same thing. I extrude the surface. So you got a 3-dimension volumes. And height, again, is controlled by the random number. So this one is between these two values. Okay, so this is just alternative approach. And then later I just merged them together. Basically, you get this kind of form, which is purely just based on a bunch of lines. If you consider this as urban design approach, right, the lines maybe represent the traffic, maybe represent some kind of movement, or maybe some diagrams come from GIS. Right? Then you convert that into a 3-dimension diagram. You have questions?
Yeah. The random one, since it's random, does that mean that like if we were to disconnect or disable and then reconnect it or re-enable, would it constantly change what that random is?
The random is only actually computed once. Once it's computed, the number is kind of static. I understand the question you have is if I want to have a different set of random values. In that case, you have to control the seed. All right, the seed is kind of like the iterations you can push through this random calculation. So right now it's 2, but you feed a different value, then it will just recompute it randomly. So seed.
If you go back to 2, will go back to that set, or?
What do you mean back to 2?
Well, you said right now the seed is 2, and if I change it to 3, it'll recompute, right?
Yes.
And if I change it back to 2, will it go back to the original set, or will it recompute again?
It will back to the original set, I think. Let's take a look. So first one is 2.4, right? It's kind of random, but it's only calculated once. So now if I change the integer to 3, see, that's different. It's a different set of random. Then if I change this back to 2 again, it's back to that number. So although it's random, but it's only calculated once. Once it's done, it's always that one. Okay, so that's a good question. So let's keep going. So we have the 3D models. Looks like a city, right? With highways, with building mass. The next thing I want to do is actually make it even more complex. I want to create some kind of frames. Look at this rendering, some frames. It's very similar like a super extrude, if you recall in Maya, right? You can take a polygon model, then when you do super extrude, every single edge became a frame. And that's a pretty intense computing. So here in Grasshopper, I want to do the same thing, super extrude. Okay. So what I will do is I will take only the massing, the building, which is half of the original model, and I will feed into this new process. Let me just enable this. Okay. All right, so I will explain one by one. So first, you have all the buildings, right? All the massing. Then you use this component. The name is the B-wrap edges. B-wrap edges. You can find this guy right here, surface, and here you can see B-wrap edges. All right. So what this do is it will extract all the edges based on a solid model. Okay. So what you end up with is all the individual lines. So here you can see EI, EN, and EM. They are just different groups, right? So if you roll over, you can see in the EI interior edges, it has 612 values. So that's quite a lot of lines. Okay. Then I'm going to take these lines to create super extrude. Okay. So the way I can do it is I actually copy paste with another definition I created many years ago. This is actually a good example. You should always add some note for your script. So in the future, you want to reuse it in other place, you know exactly what this script do. So this script basically do is it take a sequence of curve. So whatever the curve is, and then going through this process, it create a lot of frames, like a 3-dimension frames. Okay. I think one of them is getting old. Sweep. Yeah, it's still working, but just getting old. So here I have all the lines, and then I can detect. I think it's easier. Let me just draw one new line. Yeah. I will using a new curve just to demonstrate. So set one curve. So this is the only curve I have. I will use this guy to feed in. Okay. So it's easier, you can see it. So here's the result. I create a, rectangular sections for this frame. Right. So the process is first I take the curve. Right. So the curve is fed in. Then I create a perpendicular frame. Right. You can see the frame is actually perpendicular to the curve. The t values. Can someone remind me what is the t values means for a curve? From 0 to 1? Yes. Yes. So 0 is the start point. 1 is the end point. So the t value will define the location of the points along the curve. So here is a 0. So that's the start point. You can see the vertical frames is kind of lined up to the beginning, right? To the start point. And for this part, it's actually pretty simple. It's just a this is actually a polygon. So the polygon radius is 0.2. The number of segments is 4. So this is actually a square. So this is the square shape. And then I detect the center point of the square. Then I rotate the square 90 degrees. This is actually 90 degrees. And then I will align this square directly into the curve. Let me see, where is that? It's pretty tiny, but can you see it? Okay, so script is just create a rectangle square and then put that at the start point and then rotate 90 degrees. So just make sure it's kind of facing that. If you want to test, I want to change the square to, hexagon. I can change to circle. It's pretty flexible. You can control the profile or triangle. So I will keep as 4 rectangle. And then at the end, I will do a sweep. To sweep, you need to input a rail, which is a curve, the path, right? And then the section will be the square. So that's how you create a sweep, right? So that's how you do one single line. So if this works, I can just replace this single line with 612 edges, right? So you see every single edge is being converted as a super extrude. And you could definitely control, for example, I think, well, I want the thickness, right, be a little bit bigger. I can give this to 0.4, the radius for the square. Then you see the result. It's getting fat. I can make it even bigger. Oh, I think I didn't accept. So just accept. So this is the result. Okay. Super extrude. Go ahead.
I was following along on my computer, and for some reason it was having a problem reading that. Yeah, right where you are, reading that panel in the angle section.
Mm-hmm.
So I got it to work, but instead of using the panel, I right-clicked on the angle and I set the number that way.
Okay, it's the same. As long as you have the value in.
I just wasn't sure if the new version had trouble reading the panel or not.
Possibly. Yeah, maybe it's a version issue. Yeah, in Grasshopper, you can either right-click, set the values, right, from this way, or you can
set numbers and you have to deactivate the panel.
Right, you can set numbers, yes, or you can just using the panel to input. The tricky thing is when you use panel, never use enter key, because enter key will actually create the second line in your panel, which will confuse Grasshopper. because you have no idea is this a value or is a string. If it's a text string, it doesn't calculate as values. So that might be the case. Anyhow, I think I'm pretty happy with the result, right? This one, and I'm going to bake it. I will bake into layer 5, and then I will bake the highway. Where is the highway? Highway is here. I will bake it to layer 4, and I can close Grasshopper. Right, so here you can see this new model looks like that. Looks pretty awesome, right? Although I have no idea what is that. Yeah. It's a mesh. Yes. Well, I think probably you can just treat that one as a two-dimension drawing. That's two-dimension, yes. And then you just overlay those two drawings. I would recommend you only choose a small piece from your drawing. See, the drawing could be super complex, like this one, right? So if you compute this into Grasshopper, it's gonna definitely crash your computer. So I would suggest you only define the surface, right? The rectangular surface to trim, right? So define a small surface. Pick the area you think is the most interesting part, and use that to create a 3D model. It's not the entire thing as 3D. Pick a region. Could be very different from my demo. My demo just like one way to do it. You can definitely find other ways. So I would encourage you to, add something new on top of my Grasshopper. The last thing I want to show you really quick about the rendering and color. This is actually something you probably already know. So I will do that really quick. Let me switch the style to artistic. This is actually pretty cool in Rhino 5. You never use that. It's artistic. You can also do pen, which give you this really interesting, hidden line style. You see, this part doesn't have the intersection lines. See this one? So if you do want to show the intersection line, you have to manually uniting them together, pooling and uniting. It should be easy to compute if it's just simple lines. And then as a result, you should be able to see all the individual lines in between. See that? Okay, so that's a Boolean operation. You could do that in Grasshopper too. But anyway, so I have this one as two layers. So first thing I want to do is select everything in this layer, and I will set properties as material. I can control the entire layer to do a new material. I will just simply do a red color and then click OK. So I have this layer 4. For layer 5, I will do the same thing. Set material properties, give color to maybe green, click OK. So if you are in the render mode, you should see the color right here. Then I can go ahead start to render. I think I still have Visual Render as a default engine, which will give you the pretty nice, this kind of soft ambient kind of lighting. So here we go, we got the renderings. So use color as a way to define the zones. So green is one, red is another one. Okay, so this is the whole process. Yep, I think I will stop the video right here.
Is there actually a way to render in artistic or pen?
I